And we are live. Okay. So what is a binomial distribution? Well, the distribution, we still have a chart. We still have a left side and a right side. And we're on page 210. Results from a procedure that meets the following requirements. The procedure has a fixed number of trials, like 7 or 4 or 2. The trial must be independent. Doesn't affect, in other words, you replace the marble. And each trial must have an outcome classified in 2 categories. That's why it's called binomial distribution. What does bi mean?
2.
It either is or what? Is not. That's 2. Either true or false. And the probability of success remains the same in all trials. Like, what's the probability of having a girl? 1 out of 2. What's the probability of having a boy? 1 out of 2. So all these distributions, all these probabilities are going to be 50-50 probabilities. So they're going to be simple. They're not going to be like the ones we did in 5.2. And you don't have to write each one of those down word for word. You can shorten them if you need to. But I will say this. The color guard did very well. I don't see how y'all do all y'all do running around. That's both schools. I mean, they run around. I ain't seen Hannah's. Do y'all run around and do a presentation or whatever? I don't see how y'all do it.
Most time has 36 girls in it. So like if the band is in a formation, we like just kind of scattered everywhere. And this year our rifle line is in our pit. Like as I'm talking, I can't toss sideways.
Y'all didn't stay with the band?
We competed in upper state last weekend. We got third for that 4 out of 14. And we were barely fourth. We were like barely fourth.
Like almost a fifth or almost third?
Almost third.
Well, congratulations to both. We didn't hear about crescents, but that's all right. She ain't letting us know about crescents. So. Okay.
What do y'all do during halftime? What do y'all do during halftime? No.
Well, anyway, I hope Crescent does very well. I got a lot of friends down there.
Down there in Star Island.
Okay, notation for binomial probability. Write those down because you're going to see these in Chapter 5 and Chapter 6. P is the probability of success, duh. And Q is the complement, which means 1 minus P. Now this is going to be very important in the next 2 chapters. So you need to get used to doing it. N, that's always your biggest number. That's always your 30. If there's 30 people in the class, N is equal to 30. So you're going to add up numbers to get N. X denotes the specific number of trials in N trials. And I'll get to that when we do the first problem. It makes more sense when I show it to you in a example. And P and Q, again, the P denotes the probability of success and failure. What's the difference here and here? Well, this is the definition of this. I don't know why they feel like they have to repeat it, but it's not a big deal. Huh? X denotes a specific number of successes in the trial. And that will make more, you think that's what that is. No. It's like if I flip a coin 50 times and it ends up 42 times on tails. If I take that same coin, what is the probability of me getting tails 58% or 0.58? Well, then X is equal to 0.58. All right, I am wanting to know what the probability is if I use that same coin. Well, what's the probability using that coin for the 50 trials? The probability is what I say, 42. That's the probability. That's P. What's Q? Q would be, what, 58% or 0.58? What is N? I flipped it 50 times. X denotes a specific number of trials. You could put a what if out here. What if I flipped the coin and I wanted a 40% probability or 4.4 probability? What is my probability of getting tails 40% of the time with that same coin? That's what X is. So you can put a what if out there. And P of X denotes the probability of getting exactly X successes among the N trials. And we'll talk about that when we talk about our first example. So write those down and make a note that you need to highlight that, because especially those first two, you're going to be dealing with these first two for the next couple of chapters, especially chapter 5 and 7. Okay? When an adult randomly selected with replacement, that with replacement means that it does not affect the future outcomes, there is a 0.85 probability, so P is equal to 0.85. What is Q equal to? 0.15. So that's how you get P and Q. Suppose that we want to find out the probability that exactly 3 of the 5 random adults know what Twitter is. So we got we got 0.85, that's P. We've got Q, and X is going to be 3. Well, what about N? Well, it says 5 random adults. When a adult is randomly selected with replacement, there is 0.85 probability, blah, 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 blah. 5 is N. Does this procedure result in a binomial distribution? Yes. Either they use Twitter, or they know what Twitter is, or they what? Don't. It's like being half pregnant. You can't be half pregnant. All right? You're either pregnant or you're not pregnant. I mean, that's it. You're either a male or a female. So you got to read into the question to make sure that it is, a binomial probability. You can't get on there and say, what is the probability of picking picking a face card out of a deck of cards? You can't do that anymore, because that's not a binomial probability. Okay? And this procedure does result in binomial distribution. Identify the values. We already did that.
Can you do that? So N is 5, X is 3.
P is 0.85 and Q is 0.15. So the math is not that difficult. And then you're going to plug it into the formula later on. And there it is. Okay? And they haven't given you the probability formula until we get here. And there it is. Write it down. Now, you can write the formula down, or we can use it in the calculator, and I will show you how to do that. All you have to know is N, P, and X. Now write it down, N, P, and X. You can't have it in any other order, because your calculator will only take N, P, and X. Why does it need Q? Why doesn't the calculator need Q? It can figure it out. So what's Westside's record now? Aren't they doing pretty good? Huh? Football. don't know.
We won the last one.
We can find out.
I think they only lost 2. So how many games have they played? 6? 7? So they're 5-2. How about Hannah?
We
Oh, it's
have a
7.
pretty consistent
Yeah, we're very consistent.
Doing good. We're pretty consistent every time.
What did they put? Did Lucas ever get quarterback?
No.
He hadn't got quarterback.
No, he's got.
I know he got hurt. He hurt his ankle.
No, his leg was.
Oh, it broken. I don't know.
You and the mafia with his dad?
Yeah,
Y'all
we
got the
both
same-
got black hair. Yeah.
No, it's slick back.
Well, that's cause I need a haircut. That's why.
I swear to he's in the mafia. I swear to you.
They're from Rhode Island. Why do you say they're from Rhode Island?
They're
The mafia's not in Rhode Island. Yeah, you'd be surprised on how many people I know. You know?
No, I believe you. They're famous now.
No, I'm not. I am in a novel. You don't know which novel that is? Huh? How'd you know that? You read it? Huh? What teacher? Ron Rash? Oh, well then why'd you say that? You just thought you'd be included in the conversation. Okay, I understand. You want to feel included. I understand. Google Ron Rash. He wrote 4 or 5 novels. First one, I'm the sheriff, but he doesn't call me by name. He puts me in there as a former Marine that went to Clemson, and I'm the sheriff, but he calls me some other name. Second one, I'm a deputy. He calls me my name, Deputy Hubert McClure, and I beat up on a hippie. And the third one, I am a drug dealer called Hubert Toomey, Toomey, and my ancestor was a colonel in the Confederacy named Hubert Chambly McClure. And then in the fourth one, I am a mountain and a campground. McClure Mountain and McClure Campground. You have to Google him.
Anyways.
Okay. That's my 15 minutes of fame.
Anyway.
Yeah, Selena, I'm the campground.
I had to read that.
Did you?
English 102 last year.
Oh, okay. Who was your teacher? Just
Jack.
who?
Jack.
Oh, yeah. You took it here? Good. He's a good teacher. I haven't heard anything bad about him, except from people that are lazy, which I can coordinate that with my students that are the same student. I know they're lazy. So anyway,
Hey, what's that 6 and 2, by the way?
huh?
What's that 6?
6 and 2. So they're better than 5 and 2. They're 6 and 2. And Hannah is 0 and
7. However many games we've played, we're 0 and 9.
oh my gosh.
Hey, it's a
Huh?
hey, it's a rebuilding.
Well, West Side's rebuilding too.
Nah, they got a brand new
There were at least
quarterback.
like
That's
2
like
games
real
we
good.
were playing.
No, what I'm saying is we got a new coach just like y'all do.
Wait, you're a weed? You're a weed?
Wait a minute. I'm sorry. Y'all don't talk. I'm sorry.
You're a weed? You're from Westside?
No, I'm just saying. I'm saying that the West Side and Hannah coach were both hired at the same time.
And he recruited. Named Dallas Franklin.
Well, I'm sorry, I didn't hear you.
They lost me on defense.
Oh my Lord!
I'm just saying we would have kept the game close and they lost Darian Mitchell on offense. Darian can score whenever he wants to.
That's the dude in the game.
So he's a game changer and I would not let them get blown out that bad. We lose, well, it wouldn't be
We lose. But,
Nah, I believe that.
well, anyway,
But I'm a troublemaker.
you a troublemaker.
I got in trouble one time.
Our principal just
First time I ever get trouble.
Well, are you gonna play next year?
Yeah, I'm next year, but I couldn't.
I know you couldn't because you switched schools, right?
I can't play for
You can't play what?
I can't play football for West Side. I can't play.
He's still going
But you can play next year, right?
I'm senior.
He's still going D1.
All right. Well, anyway, Hannah's having problems. How's Crescent doing?
How's life without Dawson there?
I know.
Dawson was great.
Okay, let's get back to it because we're not doing math, so we need to hurry up and do math.
No, we good.
You know, we need to.
We gotta look up crescents.
What's that? We need a little tail. We need a 4H.
What's what?
What's a little tail? What's that?
Usually something with Chinese.
River gloss.
I don't know what you're talking about. Show me what you're talking
Is it
about.
standard deviation? Is that what the?
Yeah.
And what's the E? That's a new. That one.
Wait, y'all talking about River Bluff High School? It's huge.
They play Crescent and they.
Y'all beat River Bluff?
Summation.
So you can put, yeah, we can put like 7,000 in here and get your standard deviation.
That's kind of sick.
I get it.
It's like animal.
Yeah.
Y'all are 3 and 5.
Is it stacked?
Hey, we're over
Yeah.
dog.
I think we covered that. All right, read what's on the board.
Well, it's kind of cut off.
All right, hello. Read what's on the board. It says, well, something's wrong with this. I hate this thing. We got it turned around backwards. That would help. No, I don't. Yes. I got ejected. I think I do. Why? What do you got to do with it? I mean, what's wrong with your car? I don't know if I honestly don't know if I have a jack or not because I'll look, but I've never had a flat tire on the truck. And I don't know and I bought it used, and sometimes they don't have a jack, and I can't get this. There we go. All right. When do you need it? After class? Do you need it after class? All right. Given that there is a 0.85 probability, selected adult knows that a Twitter is, well, that's what Twitter is, blah, blah, blah. Here is N. We said that a while ago. X is 3. P is 0.85 and Q is 0.85. Now what this means is, given that the research shows us that there is a 0.85 probability of an adult knowing what Twitter is, what is the probability of 3 adults knowing what Twitter is out of the 5?
So that's one of 3 or 5?
The research give us this. The research has given us this.
Which is 3 or 5?
And they're saying that the research comes from 5. They interviewed 5 people. All right? They want to know what the probability of 3 of them knowing Twitter. What's the probability? If this is the probability, it says it up here, that they randomly selected what? That's 1. Okay? All right. What is the probability? Well, you got a 0.85 chance of picking that person. All right. What is the probability of having 3 adults know what Twitter is? So you would take this and plug it into the formula. Or you can go into MPX, go into stat, and we can calculate it, or into second function bars. Go second function bars, and I think it's called binomial CDF or PDF, one of the two. I'll get there in just a second. And that's why this section is so simple, because all you have to do is punch it in. And we will do that here in just a second. Go second function bars. Everybody looking on the board? Second bars. And go down to binomial. I think it's PDF. And type in N, which is 5, comma, P is 0.85, and what is X? 3, and close parentheses, and there it is. What? I'm sorry, what? Oh,
Did you say bars?
yep.
I didn't think I ever needed it again. What was I like?
Everybody knows where it is?
Nah, Mr. Cool, I need help. Oh, shoot. No, I'm not taking this.
Yeah. It just asks you, it don't ask you NP and X, it asks you to put it
You
in.
gave me one.
Not like that, but like this. So the trials would be 5, and the P would be 0.85, and the X is 3, and then enter. It just puts it in there for you.
Okay, so does that generate?
Hold on. What?
Does that generate?
Yes. So what is the probability of 3 adults knowing what Twitter is? 0.14 or 14%. You got a question? What it'll say? I just say 14% because you only, for percent, you only need 2. So. Now, your choices, are you listening? Your choices are either you can do it by hand, right here, or you can punch it in the calculator. Now, just like I told you with combinations and permutations, that's just time consuming. But if you have to do it by hand, this is how you do it by hand.
So you went in,
Second, bars,
yeah, and then the numbers in order NPX.
NPX. If you don't put them in NPX, it won't work. It's got to be in the order NP and X. And you got to put commas between them.
By PDF.
And you've got to be able to pick out your NP and X. Your N is going to be your big number. Your X is usually going to be in relation to that big number, but smaller. And then your P is going to be 0.85 or 0.35 or point something. Right now they're giving it to you in decimal form. They could give it to you in a fraction form. Like 25 out of 32 people did this. So you'd have to turn that into a decimal. These are really simple. Let's do another one.
Let's do it.
Let's go to our homework. And pull out a couple. All right, try that one. It says assume. Yeah, I know. Assume that just leave. Assume that a procedure yields a binomial distribution with n is equal to 3. Well, that kind of narrows it down a little bit, doesn't it? And a probability is 0.8. Use a binomial probability table to find the probability that, you don't have to. Number of successes is exactly 2. So what would NP and X be?
3.8 and 2.
So you take your handy dandy calculator and you hit second entry and backspace, and that's going to be 3.8 and 2, and you have a 38% chance.
Well, X will always be smaller than.
Always. But please realize what you're doing here. Please realize, use a binomial blah blah to find the probability that the number is 2. So the research tells us that the chances of success is what? P is equal to 80. But that's based on the research that we've done before. All right. Now it's saying find the probability that the number of successes is exactly 2. This is based on probably 1. They want to know what it is based on 2. Okay. So you see, I could put 3 or 4 of these on a test. You should get them right. You should get them right. Oh my, this one puts it out of order. This one you don't even have to read the question. All you got to do is type in NP and X. So some of you that's on the silent calculator team at school, y'all can, twirl it around on like a basketball on your finger, with these. So you hit second function, entry, unless you just like to type. And that would be 5. Can't type it in the order it's given. 0.25 and 3. You got a 9% chance. Okay, we're going to have to do something to discourage you a little bit. All right, read that one. Now this is where we take the easy stuff, but you got to think a little bit. So I might as well forget it. Just quit. 10 P's are generated from parents having green, yellow pairs of genes. So there is a 0.75 that a individual P will have a green pod. Find the probability that among 10 offspring, at least, now if you write this question down, you need to highlight that right there. Have green pods. Is it unusual to get at least 9 P's with green pods when 10 offspring P's are generated? Now this problem, you can't do it unless you understand what this is. What this is. So give you a minute because I want you to think about it. And think about at least 9. What at least 9 means. Yep. So that means you got to do something with 9 and 10 probability. So work it out. Means you're going to have 2 NPXs. One NPX is going to be 10, 0.75, and 9. What's the other one going to be? 10, 0.75, and 10. But you got to do something with those 2. Think about at least 9. What is at least 9?
Greater than or equal to 9.
Yeah. You should add them. So get those 2 together and figure out what you're going to do. That's going to be NPX Oh well. Make sure it's down. Got to write on the board sometime today. Okay, that's not going to work. Goodness, it's not working. Not working.
There it is.
No, it ain't gonna work right. So I'm not gonna leave it alone. So you're gonna take NPX, so 9 or 10. P is 0.75. And X is 9. And you're going to add 10.75 and 10. Now the reason you set this up like this is because at least 9 means that the lowest number is what? 9. So you're checking the probability of the 9th and the 10th trial. Because at least 9 means the lowest number is 9. So you're checking the 9th trial and the 10th trial and you're adding them together. So take your handy dandy calculator and second function entry. And you can put them in, I'm going to show you how to use memory because you're going to be needing that in the future. So that's going to be 10. So insert 10 and delete. And 0.75 and 9. And I'm going to store that. So stove, like you go to stove. And alpha A. And then you take this one, so second function entry, second function entry, and 10. Enter. And multiply that by, or sorry, add it to alpha A. And I get 0.244. So you got a 24% chance, or is it unusual to get at least 9? That's what it says right here. So the probability of at least 9 of the 10 is what? What did we get for that first one? 0.056. Oh, the second one. I'm sorry. Oh, it's on up there. I can't get up there. Oh well. How much? 0.188?
Yeah.
It says it's not. Okay. Okay. It's asking for both of them because that's what I get. Didn't I get that? 0.244? Yeah. Okay. And then, is this unusual? Well, again, go back to your 5%. 5% is unusual. So what is this one? 24%. So it's normal, isn't it? It's normal. So you would say, is it unusual? And you would say, no, it's not unusual because this occurring is what? Not small. Should be that one. Huh? Why? I think it's pretty straightforward. Oh, these? Okay, the unusual questions are okay because all you got to do is compare your answer to 5%. If it's less than 5%, then it's unusual. If it's more than 5%, then it dips into the 2 standard deviations, and that means it's normal. All right, let's try nerd. Try that one. This is number 17. A TV show, Lindsay and Tobias, recently had a share of 15, meaning that among TV sets in use, 0.15 were tuned to that show. All right? Assume that the advertiser wants to verify that 0.15 share value by conducting its own survey and pilot survey begins with 18 households. Blah, 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 begins with having sets in use at the time of Tobias. Find the probability that none of the households are tuned to Lindsay and Tobias. So what would none be? 18.15 and what? 0. So do that. Let me ask you a question. Is the math the problem on these problems, or is it picking out? It's picking out the math. Picking out what you need to do. So you're going to have to think. Your calculator won't tell you that. I'm sorry, bad here. What's this 6 cents for? No, it's simple math and critical thinking. If your bill is $19.56 and somebody gives you $20.06, that's simple math. And if you're running a cash register, you ought to be able to do that in your head and not have to reach for a calculator or ask the manager what to do. Heaven forbid you ever have me as a customer if you can't do that, because I will make your life miserable. 0.15 and 0. I get 0.5%, or 0.05, which is 5%. What do they say? Round to 3 decimal places. What is that? 0.054? No, it's 0.054.3. There. Now do this next question. Again, you have to think. Miss White, you need to cheer up. Miss White. At least 1. That means that 1 is the smallest what? So you need to find the probability of 1 through 18. What? At least 1 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 18. Punch them in.
You can't just do 1 and 18?
No. Got to add them all up. Or you can do something else. Can you what? Who asked that? It's called the what? What is that called? Starts with a C. Yeah, common sense. But it's called mathematically the what? The complement. I was going to see how many of you are going to type in 18 different ones. So, this is the complement, because it says, I wish I could draw it. I can't, because I can't use the pen. How many houses are on the thing? 18, right? So 0, 1, 2, all the way up to what? 18. All right. We have this one. We have the probability of what? 0. They want the probability of what? 1 to what? Now, if we know the probability of all of them is 1, and we know the probability of this one is 0.054, then what do I need to do? This to this is 1. In other words, the probability of 1.00. We have found the probability of 0 is 0.054. So if I wanted to find the rest of them, I subtract 1 of 0.054 from 1, which is 95 cents, and then take away the 0.6, or the 0.6, it would be what? 94.946. Somebody subtracted, is that what you get? Of course it is. 0.946. And you feel good about yourself.
Such a great day and excellent.
Yep. I'd love to be able to put the comments in there, program it in there, in case you got it wrong. You suck. Wouldn't that be funny? Somebody doing their homework one day, get one wrong, and it says, you could live in a ditch.
That'd be so funny.
All right. You should quit school. Find the probability, oh gosh, that at most 1. At most 1. What does at most 1? That means your highest number is what? So what would that include? The probability of 2 things.
0 and 1.
0 and 1. You would be surprised on how many students just sit there and stare at that. The reason they stare at it is because they don't know what this means. At most, that means that the largest number is 1. So if the largest number is 1, then you're just going to take 0 and 1, probability of 0 and 1, and add them what? Add them together. Well, we know the probability of 0, so we just got to type in the probability of 1. And that's going to be second function entry. And that's going to be 18.15 and 1. And I'm going to add that to 0.054. And it's probably going to be off a little bit because I didn't use the original 0.054, so that's 0.224. So it may be off a little bit. No, fantastic. You will not live in a ditch. No, I'm finished with the problem. What?
With B, what were you subtracting? With B?
Oh, B, you take 1, which is the whole probability, and subtract the probability of 0. And that gives you the rest of them. If at most one household is tuned to Lindsay and Tobias, does it appear that the 0.51 is wrong? Well, what did we get? What's that percentage? So is the 15 wrong? Well, you got to find out. New minus old over old. Take 0.22 or take 22 minus 15 and divide by 15. What do you get? You got to do it. What does it come out to be? I'm sorry. Okay, it's 0.46. What it 0.46 or 0.046? It don't seem like that's right. I know. I'm just saying it just seems awfully high. That's a 46% increase, I guess. 15 to 22. It just don't seem right. Do this. 15 minus 22 over 22. Try that. What is that? That seems more like... What? 0.32. No, it's an increase of 46%. And you said it's 0.46. It's higher than 5%. So does that mean, let's see, does it appear that 15% is wrong? I would say yes. Because the 15% rate, the probability of most households is greater than 0.05. But that 46 seems awfully large.
Just check it out.
Nope. Well, it's B. Oh, there's the no right there. I said. No.
said yes.
No. If at most the household is tuned to Lindsay and Tobias, does it appear that the is wrong? It says no. I understand because it's greater than 0.5 because you got 46%. But, it's greater than 0.5. So that means it's normal, and the normal means that it's not incorrect. It's not wrong. I hate those. I hate those. The 46%, she came up with 46%. That means it's greater than what? 5%. If it's greater, that means that it's normal. So if it's normal, the answer, the 15%, is not what? Wrong. You have to think about that one. I didn't think on that one. All right, let me get the roll, and then y'all can skedaddle. Make sure you get 5.2 and 5.3 homework. We only got one more section that I'm going to go over, and then I'll give you the Chapter 5 test, but I don't know which section that is right now.
Are we not going to do that 4.6 or 4.4 homework?
No.
Are we ever going to go back to that one? No.
I covered 4 sections out of Chapter 4. I don't know what they were. Y'all tell me what they were.
I was just seeing if we were going to go back.
We don't go back.
I'm not gonna need it. I'm gonna just take him, her, to handle it, and then I'm gonna make it back to West Side.
Okay. All right, go ahead. Yeah, man.
I don't. Just ask him. I don't.
You just
I mean, if it's going to be used, then I can, people can use it.
are you